So I'm going to talk about debugging tools for C++. In particularly about time travel debugging, JsDbg, and how to make GDB faster. C++ debugging, as we all know, is difficult. There's a lot of issues with it. GDB is slow. Can be very annoying to explore your data structures to find out what's wrong where. And there's no good way to see how your variable got its wrong value. So those are all issues that I have solutions for. So GDB performance, for me at least, that's probably the most annoying issue about debugging. So I spent some time looking into this. It turns out that the GDB init file that Chrome provides for you all to use is slow. It turns out that it was running Git for every library that gets loaded. And that turns out to be very slow. It used to find a source directory, and it turns out that it doesn't change from one library to the other. So I landed a patch. Now it's only running it once, and now GDB is 20% faster to attach to Chrome. All these measurements are from a debug component build, which I assume is probably what many of you use. Then I looked into GDB itself. GDB, when it attaches to a process, it demangles basically all the symbols. And because the demangler has a tendency to crash an invalid input, it catches segfaults so that GDB doesn't crash with it. But it does that in a slow way. And this is now fixed in GDB trunk. But you can also get the performance benefit right now by setting this GDB setting. As long as you don't have weird symbol names, this should not be any problem. And you get another 14% speed up. Turning off CPU frequency scaling is a surprisingly big benefit. I got like several seconds faster GDB startup, which I was quite impressed by. So you can just run that command even when it's not a laptop, even on a workstation. And finally, the real improvement, I guess, is from making symbol loading multi-threaded. So some GDB developers were working on that already, and I built on their work. And there's a pending patch now to load the symbols in the background thread, and you can get a total speed up from 60 to 75%. So with everything I've done here, I got the GDB startup from about 50 seconds down to about 8 seconds. But the multi-threaded loading may possibly come to the next GDB version. Thank you. So the multi-threaded symbol loading might not make it into the next GDB version. It might be the one after that. But yeah, that should happen soon. And if you ask me, I can point you to the patches you can apply if you want to compile GDB yourself. So that's one big pain point solved. Now I want to talk about JsDbg. And I'm going to give a demo a little bit later. But basically, this is what it looks like to sort of introduce it before I talk a little bit more about what it does. But basically, it lets you interactively explore your data structures. And there's a number of extensions already in JsDbg. So you can look at, in this case, this is the layout tree. But there's also extensions for the DOM tree, the accessibility tree, the fragment tree. I think there's something for the compositor. Some direct 3D thing. I'm probably forgetting a couple. It's also easy to define others. So the way this works is it's a plugin for various debuggers. There's versions for WinDebug and Visual Studio. And by the way, JsDbg was done by Microsoft. And I ported it to Linux, to GDB. There's no LLDB version right now. Somebody should feel free to volunteer. Shouldn't be too hard to do. But so basically the way it works is you use your debugger as usual, and then you type a command or click a button in Visual Studio, and then JsDbg launches. So that way you get an easy way to look at your various data structures, and it just makes it easy to inspect the various objects in your layout tree or in your DOM tree. Instead of having to keep typing commands and copying pointers around. And it's extensible. So if you want to add support for a different data structure or even for a different browser, I think I talked to some people recently who might want to extend this to Firefox or WebKit. But anyway, it's fairly easy to extend this, and it's just an easy way to look at what's going on.
Richard.
And because the way it works is that it gets all the data types directly from the debugger, it's easy to extend. So you don't need to teach it that a layout object exists and it has a size and a children pointer, a first child pointer, and the next sibling pointer. It already gets all that from the debugger. It also automatically finds all the trees that exist. So there's a global variable in case of Chrome, which has a pointer to all the...
No, uppercase arm.
What?
It's not on brand.
I forget exactly what it points to, but basically you can get to all the DOM trees through it, and through the DOM tree you can get through all the layout trees. There's a similar pointer for the accessibility tree, and so you don't even need to paste any pointer values into JsDbg to get there. So it mostly works automatically. You just need to tell it you need to tell it how to get to that root pointer for the various trees, and you need to tell it how to get the children of a pointer. And this is already predefined for the trees I mentioned earlier. You can also extend it easily to anything else. And I can show you how this looks. So let me increase the font size. So when you run JsDbg, you get a list like this, and then you can see what you want to look at. For example, if you want to look at the layout tree, just click this. It already, in this case, there's only one, but it's content shell, so there's only one layout tree. But it automatically finds which one it is, and now it loads. Now it loads all the various types from the debugger and the contents of those nodes. So we can see up here that it finds all the roots. In this case, there's only one layout view. But if you were to use this with a full Chrome process, you could see all your tabs up here. Then what I recommend doing is that you show all the values for the layout-ng text objects. And I also like enabling the sizes of the boxes. And so then you can easily find out the structure of your tree, and you can find which object you're interested in. So usually between the text and the types of the objects, it's easy to see the one that you're interested in. Then you can just click and see all the members. You can look at the style. You can see the values of the enums, which are pre-printed. And you can keep looking through that. And then if you like, you can also, there's some predefined extensions to easily get to things like the layer, the physical fragment. And similar things have been done for the DOM tree. So it's just very easy to see what's going on in your tree. And of course, you can always add other things that you want to see for every node up here. You just need to click at it on the right side here. So next up, I want to talk about time travel debugging. Did you ever wonder where a variable was last changed? Where did it get its value from? Did you ever want to go back a line to figure out where that value why that function returned the value it did? Did you ever want to get the call stack of the previous time a function was called on this object? Now you can. At least if you're on Windows or Linux. I'm not aware of a version of this for Mac. But On Linux, Robert Callahan and Kyle Huey made this thing called RR. I think it stands for Record and Replay, which you can download from this website. You can compile it yourself, or Debian and Ubuntu have a package for it. On Windows, you can use JsDbg Preview. It's available at the Microsoft Store. And yeah, JsDbg Preview, of course, is a little more user-friendly because it's has more GUI, does buttons to go back and forward. So I'm not going to talk about that one too much, but the concepts are very similar. The exact commands are, of course, different. But the way all of this works, both of them work. First, you record an execution of a program, which gets saved. And then everything you do happens based on the recording that you did. So in case of RR, you interface with the recording using JsDbg, and so it provides some additional commands for that. And the most important ones are the ones here. Basically, reverse versions of next, continue, step, and finish. And they basically work the way you expect it to. So reverse next steps back by one line. Reverse step goes back and steps into the function that was last called. And reverse continue just executes backward until a breakpoint is set, or until the beginning of the program. Reverse finish goes to where the function was called instead of where it returned. So in a simple case, you just record a trace. I think you do need to disable the sandbox. The single process is actually optional. I do like using it because it makes it a little easier. You don't have to figure out which process is the one that you were interested in. But I'm going to talk later a little bit about multi-process usage of this. And then all you do is type RR replay, and you're in JsDbg. And yeah, so once you're in JsDbg, you can use it as normal. You can continue. If you just type continue at that prompt, you get to the end of your recording. So usually what I do is I go to the end of the recording, and then I go backwards to the last thing I'm interested in. So what you can do, one thing, of course, you can do is you run JsDbg, then you see your tree, and then you can start setting breakpoints on the node that you cared about. But here I'm going to talk about a few features that are really useful. So for example, if the width of your layout object is wrong, you can set a watch point on that wrong width, and then you just reverse execute, and it'll stop at the point that it was last changed. So and then it looks like this. So it'll tell you the old value and the new value, and then you're stopped there, and you can get a backtrace there. You can inspect your variables just the way you would do normally. There's also a checkpoint feature. So if you're stopped at the place and you want to keep track of where you are, and then so you can come back to it later, all you do is type checkpoint, and later on you can type restart, and you go back to that checkpoint that you set. You can set multiple checkpoints too if you like. And of course, this works well with conditional breakpoints as well. So if you're stopped at one update layout call, and you want to go back to the previous time it was called on that object, you set a conditional breakpoint, reverse continue, and it'll stop there. So normally these traces are specific to your machine. It uses symlinks for various things and other stuff. But if you want to transfer the trace to a different machine, so you can replay it there, you can pack it, use rrpack. And it'll tell you the directory it's in, and then you can copy that elsewhere if you like. You probably have to disable debug fission if you do that. And you can also use that if you want to replay the trace after recompiling, because normally that wouldn't work. And this is how you would do it if you do multiple processes. So if you don't use single process for your content shell or Chrome process, you can afterwards, after recording, you just do rrps, and it'll give you a list of everything, of all the processes that it recorded. And then you need to find out which is the one that you're interested in. So for example, you can use, well, either you can look at the list, and maybe you can already tell from the command lines which is the interesting one. Or otherwise, you can do replay-m, and it'll annotate each line of the output with the process ID. And the second thing is called the event ID. There's another command that you can use to go directly to that specific point in time for from your trace. But anyway, so if you find your process, all you do is replay-p, and then you give it your process ID, and then you're looking at just that process. Yeah, I mean, I could also give a demo of RR in particular, but I think the interesting stuff was in the slides. Yeah, do y'all have any questions so far? Yeah.
So for the multi-process example, the last command was RR replay.
No, no. So recording is exactly the same as always. RR will always record every process that gets launched from your program. And yeah. The question was, is there a way to record a process that's already running? I don't know the answer to that. I don't think so either. Okay. Sanket tells me on Windows you can do it, but not with RR.
So if I understand your example right, you would run PS while the process is going to get the...
Oh, no. So what I meant is you just record it as usual, and eventually you either press Ctrl-C or otherwise exit, and then you have your recording. And only after the recording that you can do the RRPS thing.
I see. Okay. Got it. Thank you.
So RRPS basically tells you the processes inside of that last recording.
How much slower is it while running onto RR, and like what's the size of the output?
It's actually, it's not much slower, especially while recording. So recording and running forward is pretty fast. I didn't do exact measurements, but it doesn't really feel slower. Reverse executing can be a little bit slow, like reverse next can take a few seconds. But yeah, it's pretty efficient. The Windows 1 WinDebug preview is much faster than RR for the reverse execution itself. Oh, you asked about the size. Actually, hey, I have a recording here. I can look. Apparently, in this case, it's 5 gigabytes.
I think it's because it's packed.
Oh, this one might, maybe, yeah.
In my experience, they're not that big. Like,
Oh, wait, it was the wrong command anyway. This is really what I wanted. But anyway.
in my experience, they haven't been that big. Like if I just did a minute-long trace or something, it would be tens of megabytes. So I assume when you pack it, it puts all of the symbols and binaries into the folder so that you can send it to someone else, at which point it grows to 5 gigs. Just for normal.
David thinks they're more about a gigabyte.
Content shell versus
Chrome. Does the RR replay play nice with the GDB scripting?
Yes. Yeah, everything works normally inside of GDB. You can also combine it with JsDbg, which I actually did in my demo. You can use any other script. You can even call functions inside of the recording.
That's actually one of the interesting parts. It forks the process to run the function call because it can't continue executing a program after you've possibly changed state. So interesting side note.
I think what it does is it sort of forks a new process, and then there it calls the function.
Yeah.
So you cannot modify the state, yes.
Is the packed version faster or slower to replay?
Is the debug version, you mean the debug of Chrome?
Yeah, you packed the you packed it for sending to another machine. On that other machine, is it slower?
Oh, once you pack it?
Yeah.
No.
Hey, thanks for the talk. I'm just wondering, what exactly happens when you pack the execution? Does it only pack the binary debugging symbols? I guess it doesn't pack shared libraries and all dependencies of executable.
Yeah, it doesn't pack the system libraries. It packs all it packs all the libraries that sort of are part of the. I haven't looked at how it determines what's a system library. I assume it excludes stuff from /user, basically.
Yeah, but it would be hard. Like the packed binary or whatever it is, it would be super large then. If it's like Chrome, well, Chrome doesn't have that much dynamic dependencies, but anyway. And the second question is, if I'm not mistaken,
It
conditional.
does have some system libraries, I think. Anyway, sorry, yeah, go ahead.
Conditional breakpoints is, if I'm not mistaken, a regular GDB feature. Right?
Yes, that is true.
And it's if the breakpoint, if the place you put your breakpoint is in the hot path, then if I'm not mistaken, my last experience was that it makes a GDB slower to execute. I mean, conditional breakpoints. Is it the same for RR?
I haven't really noticed that being particularly slow. I guess it depends on if the thing that you set the breakpoint on is hit a lot otherwise.
I think if it requires evaluation, it's significantly slower. Like it
Right.
is the same as running GDB.
Well, if it requires things like making a function call, then it'll be slower.
Yeah, the value of a variable can be evaluated without calling into the program. And I think it doesn't support calling functions when you're reversing, which is...
Maybe, I don't know.
How does it work with the GDB server, like for Android? Like how would you do this?
So you cannot use it with ARM. If it did work, the way you would do it is you'd record on the device and then replay it on your desktop, but it doesn't support ARM, so sorry.
So that was basically my question. But is there a path to get it working on ARM? This would be hugely helpful for Chrome work.
I have heard that apparently a lot of the ARM processors don't support the performance counters that this relies on. So I don't think that's going to happen. I've heard there's this other tool, undo recorder, undo.io, but I don't know anything about it. I think you have to pay for that one.
Also, have you had luck with capturing a trace on one computer and then replaying it on another?
I haven't actually done that myself.
Okay.
I thought that it should.
Rob and I tried this, and we ran into a bunch of issues. It'd be great if we could get that to work, because it'd be really helpful for debugging like somebody else's issues.
There is an IRC channel where the developers hang out on irc.mozilla.org, /RR. You can ask them. I'm sure they'll be helpful.
Hey, I'm really interested in taking advantage of all these GDB optimizations to make GDB faster.
Sure.
And so I am kind of familiar that there is a GDB init inside the Chromium repo. Is that the one that you contributed to or changed to make it faster?
Well, I made a couple of changes to the one in the Chromium repo, but mostly I actually modified GDB itself.
Cool.
So that's not released yet.
So if
Some of it is going to be part of the upcoming release next month. It's not clear whether all of it will be.
So if I use that GDB init inside the Chromium repo and also get a newer version of GDB, is that all I need to do to make it as fast as possible?
Yes, once that version exists, yes.
Awesome, thanks.
There was this one command that I mentioned, that main stat catch demangler crashes. That is not part of the Chromium GDB init. You can set that right now to get those, what was it, 14% speed up. I didn't want to put that necessarily in the Chromium GDB init because there's a risk that your GDB might crash.
One other question. Does it support JITs? Would we be able to debug V8 as well?
I didn't try, probably. Like, I mean, it'll record everything. So in as much as, I mean, I don't know how you debug it, JITs.
Yeah, to the extent that GDB can debug JITted code. you can come out the other side of JITted code, and so your stack trace might have some JITted code in it, but
Yeah.
I've never actually tried debugging JITted code.
Yeah, I encourage you all to try this together with JsDbg because it's useful. But what I often do is I run this thing, and then I look at JsDbg to find the right object, and then I set a watch point on a member of that object, and then I reverse execute to find where that changed. Bless you. All right, any other questions?
Oh, sorry.
So you kind of touched on this already with the V8 question, but I wanted to ask if you have any ideas for kind of connecting C++ debugging to JavaScript debugging, because I often find that I'm like in the C++ debugger and I'm looking at a stack trace and like I understand everything up to like the API entry point where some JavaScript is calling it, but I have no insight into what's below that.
I have no experience with that whatsoever. So if somebody else in the audience has something to share.
I mean, I have a vague, crazy idea. You know, similar to evaluation, you could imagine forking the process and then attaching the inspector. But I have no idea how you would do that off the top of my head. But hypothetically speaking, it might be a thing you could do.
That's interesting.
So to give a similar answer to that, I was previously on the Chakra team, which was the JavaScript engine in Edge, and we would use time travel debugging there. We didn't use JsDbg, but we had some extensions in WinDebug that understood how to understand JavaScript stack frames. I believe that V8 has some similar functions in GDB or that work with GDB, and so you should be able to, as much as GDB, as people say, can understand the stack frames. If you get to some point where, hey, there's some interpreted, some JavaScript code happening here, whatever support there is in GDB, you should be able to use with it. You could also, if you teach JsDbg, hey, given this particular variable, I think one thing we did for Chuck was we also had, I think in JsDbg, given here is a memory address, I promise you this is a JavaScript object, tell me about it. It knew how to go and do the unpacking of, well, if this is a JavaScript object, then it will look like this, and so it should have these properties. And have some of the knowledge in there. So if someone with knowledge of V8 went and wrote that, you should, in theory, be able to use it. But it depends on someone doing that and it being possible to do before V8.
All right. I guess that's it. Thank you.